So as the title says, it's Cypher for the SQL developers. So I'm making the assumption that you're reasonably comfortable doing things with SQL. I'm going to introduce how would you do similar or the same things using Cypher. So here's a bit of a map of what we're going to do. So we're going to drive the whole thing is going to be working with the data set. We'll kind of have a look, how would you go about modeling? We'll have a look at how you import data in both tools. We'll have a look at little bit of a look at data integrity. Obviously, we'll spend a bit of time doing some queries. And then we'll kind of spend a bit of time migrating into the relational database world, or we call it refactoring in the graph world, and then we'll close up with a bit of stuff on query optimization and one of my favorite features that's coming up in Neo4j 3.0. Okay, so let's get started. So if you like football or soccer, this is going to be fun. So we're going to use a transfer market data set, and if you're not familiar with it, I will explain it. Hopefully it won't be too complicated to grasp the concepts. So there's a website called Transfer Market, and it has football transfers. So I think this is quite similar to how it is in most sports. It's possible for players to go from one team to another, and they'll pay some sort of amount of money, normally depending on how good the player is. So here's a table showing the top transfers from last summer, and we're able to get those to get hold of the data for the last 20 years or so quite easily. So I'll just show you what the data set looks like. So you can download it as CSV file. I imagine if you wanted to get it in another format, you could do that as well. So I've got it as CSVs, and so this is what this is not the whole data set. It's just it doesn't fit on one slide. So I've got a few slides showing it. But this is what it looks like. So each row is representing one transfer. As you can kind of see, we've got a season that explains when the transfer happened. We've got some information about the player. We've got an identifier that you can see there in the third column. Then we've got some other data about them, such as their position and the age they were when they got transferred. I guess ideally we'd like to have date of birth, but they don't have that there. They just have the age, so we'll work with that. Then we have information about the clubs involved in the transfer. So there's always the seller club and a buying club. So here we've got the information about the selling club, such as their name, the short name that they're named by, the country they come from, and then an identifier for that as well. And then we've got the same thing for the buyers, so exactly the same fields. And then finally, we've got some information about the transfer itself. So there's an identifier for that. There's a transfer fee, and then they also give you a rank. And so what a rank is it means what number transfer in terms of value was it for that transfer window. So transfer window is a time when transfers are allowed, and there are two in European football at least. Okay, so let's have a look. So we've got this data set. Let's say we want to do some queries on it. We're gonna put it in a relational database, and we're gonna put it in a graph. So the relational database is Postgres. That's what I was using on my machine. But I think I've used SQL that would work on any SQL-based database. But first, let's have a look at a relational model. So this is the one I've come up with. And if you think you've got a better model, all the code that I use in this talk is available on GitHub. I'll have the link on the last slide. So obviously, feel free to grab it and play around. And if you can come up with a better model, then that'd be really cool to see. But what we've got here, so on the left-hand side, we've got the players, and we used an identifier to identify each player. We've got some metadata about them, so we've got their name and position. And then we've got connection here. So this is representing a foreign key to primary key relationship. And we're saying, well, in the transfers, there's going to be a link called player ID that goes into the players table. And then we've got the transfer tables sitting in the middle. So it's linking to the player one, like I mentioned. And then on the other side, it's going to link to the club table twice, once for the from club and once for the to club. And then around that, we're capturing the player's age on the transfer. We've got the season, and then we've got the fee. Okay, right. So that's our relational model. So that one should be if you're familiar with SQL and relational databases, that's hopefully not too surprising. Now we're going to have a look at the graph model. So here's the equivalent of how I would model this as a graph, and it's reasonably similar. The concepts are pretty much the same, but we'll go through these in case you're not familiar with the graph terminology. So this is an example of a graph. I've drawn this in a tool called Arrows, which you can send a link to afterwards if you're interested in that. And so it's a tool for easily drawing graph diagrams. So let's get into a bit of detail. So highlighted in red at the moment are what we call nodes, and those are reasonably equivalent to records in a relational database, so like a row in a table. And you can see there that we're representing the bits of data that we've got. So we're representing a club, that would be a node, a transfer would be a node, and then a player would be a node. And you'd have individual ones of those for each player and for each club and so on. Then connecting them, so those arrows that you can see in there are what we call relationships. And so those are the equivalent of the join in the relational database. So it's not the primary key, foreign key, it's the actual join. And the difference here is that the join in a graph database is actually pre-computed, so it's actually stored when you write write a transaction, as compared to a relational database where you would compute it when you run your query, obviously excluding materialized views in that comparison. So that's the relationship. So we've got nodes, we've got relationships connecting them together, and then the boxes highlighted in red are properties, and so those would be quite similar to the fields or columns that you'd have in a relational table. So you can see on player we've got a name and a position, whereas on transfer we've got a fee and a year. One difference to keep in mind is that just because two nodes have the same labels, so we're going to get onto those. So labels are the names written in the circle. That doesn't mean that you have to have exactly the same properties. So the schema is a bit more flexible than what a relational database provides. Which then leads us on to the last slide, which is labels. So these are ways of grouping nodes, and so it allows us to very quickly go and look them up and find them. And we'll have a look at that when we do some queries. I'll point out where it is we're using a label to go and find something easily. Okay, right. So those are the models. So now we're going to have a look. Let's have a look at them side by side, just to get a bit of a comparison of them. So on the left, we've got relational model, and this one you'll be familiar with. So you have very uniform structure. So we've got the records in the tables. So we've got a table here, we've got one here, and then we've got what I've called soft relationships connecting them, and that's indicating that it's actually computed at query time and isn't actually stored on the disk. And then on the other side, we've got our nodes, and those you can see they have they don't necessarily have exactly the same shape. So this is indicating that they don't necessarily all have to have the same properties. And then the other difference is that the relationships are actually stored in the database. So these are not computed. These are actually stored when we write our transaction. And we'll have a look at some examples of writing those. Okay, so that's our overview of the two models for the database, and we're going to do a couple of iterations on this data set. This is our opening one. Okay, so what we're going to do now is we're going to have a look at how to import some data into our relational database. And what we probably do with the following examples is put them all into a P-SQL script, but I'm just using pure SQL to do it, just to make the comparison easier. Okay, so right, so we start off. So we've got to create our tables. So we'll start with the players one. We probably write a query something like this. So we create our table players. We go, okay, I'm going to have 3 fields. They're all character based. So remember the URI is going to be our ID. So we've got ID, and it's going to be a primary key. Is incorrect. So that should be saying actually this is the primary key. And then we're going to have a couple of other fields on there as well. And then to insert the data, it's just some simple insert statements. So we're just going to iterate through our CSV file. We're going to create some insert statements. So we're going to insert, and then we've got the ID, the URI. We've got the name of the player, and then we've got their position. Then we're going to do the clubs table. So we're going to create the clubs, and the clubs table is quite similar to the players one. So we've got an ID again. It's going to be URI. We've got a name, and then we've got a country. And we'll do a similar sort of exercise there. So we'll go iterate into club and which country they're from. Right, then third, we're going to do the transfer table. So this one's a little bit more interesting. So we kind of start with the same. So you've got the ID as the primary key, then we've got a bit of metadata, so we've got a fee. We've got a numeric fee. This is a field that stores, so the fee, if you can remember, was kind of pound 6.75 M. So we can translate that into a nicer representation so that we can do some querying on it. We've got the player age in there, and then the last 3 fields where it's interesting, where where we're saying this the value that goes in this column needs to reference the ID column in the players, and then equivalently for the from club ID and the to club ID. And so that's, so now we've got all our tables set up, which means that all we've got to do is go and put the transfers in, and we do it like this. So there's just a few more fields. Otherwise, the pattern is exactly the same. So this is probably quite familiar to you. So create the table, insert the data. That's all we're doing. So we've got that. So that gives us, now we've got a relational database ready to go and ready to query. So let's have a look next at what would the graph equivalent of that look like. So there shouldn't be anything, hopefully nothing unusual so far. That should be all quite familiar to you. But let's have a look. If we were using Neo4j and using a graph database, what would we be doing instead? Okay, so what I'm going to use, so there's several. If you look around at the documentation, or if you Google around Neo4j, there's lots of ways that you can get data in. The one that we're going to look at in this session is a tool called LoadCSV, and so this is built into the Cypher query language, which we're going to be demonstrating. So don't worry if you've not seen any Cypher before. We'll do a little bit of an intro to it to start with, and if you have, then hopefully you'll pick up some interesting ideas. But effectively, this tool is used for sort of small to medium data sets, so anything up to about 10 million records, it's probably going to work reasonably well. And then if you go beyond that, there are some other tools that we've got which you can have a look at instead. And the way that it works is everything is operating using the transactional channel that Neo4j has, and we're effectively using Cypher constructs to define the graph. We'll have a look at what that means right now, in fact. So this is the structure of a load CSV command. So this is the outlines of what it can do. We'll go through each bit in turn. So the first line is using periodic commit, and what this is used for is to say, so if you don't put this line in, it basically means I'm going to process the whole file in one go and create everything all in one transaction, which actually will probably most of the time is going to be okay, but if you're working with really large files, it might be that you actually think, I think it would be better to flush this every now and then. And so you might choose, for example, every 1,000 rows, I'm going to flush what I've got, and then we'll continue from where we are. So that's what that's useful. Then we've got the main clause. So it's kind of reasonably self-explanatory, I think. So we're saying I want to load a CSV. In this case, I'm saying with headers. So it's got some headers. If you don't have headers, then you can exclude that bit. From and then you provide a URI, so it can either be file or it can be a HTTP URI. And then as row is just an identifier that we're going to use to iterate through the file. So you can name it whatever you want if you prefer a different name than row. And then these are the Cypher constructs that I mentioned on the previous or few slides ago. And so there are three main ones we're going to look at. So we've got match. Match says, hey, database, go and find me some stuff. So in this case, what we're saying is, hey, go and find me something. So in a node that has a label called label in this case, and has a property which we're going to get from the header. So remember this row here, match is the same as this one. So we could do that if we already know there's some data in there. We want to look it up and match it to our CSV file. We could do that. If we want to create something and we know there's definitely nothing in there, then we might choose to use the create command instead. It's exactly the same otherwise. So you're saying I want to create a node that has this label. And we're going to use this information, this value from the CSV file, or I might choose to use the merge clause. Now the merge is the combination of the previous two. So this is well, if it's already there, the bit of data I'm trying to look up is already there, or trying to create is already there, then don't bother creating it. But if it isn't there, then create it. So it's kind of the combination of the two, and that's reasonably equivalent to the upsert in SQL. Okay, so there's our overview of importing using LoadCSV. So let's have a look. Let's have a look at actually using it on this data set. So the other thing that you can do, and I think it's quite a nice thing to do when you start, is to you can actually use this tool to explore your data set rather than using perhaps some command line tools. And so what we're doing here, so we're just doing a simple query. So we're saying I want to load the transfers.csv. And I want to get back the count of how many rows there are, effectively. So tell me how many rows there are in this file. So it's quite a simple one. So you can see this is how many transfers we've got. So we're working with 6,000 transfers. So there's our simplest load CSV query that we could do. And then we might go, oh, what does it actually look like? Is it actually loading my columns as I expect it to? from the file. So this time we're going load CSV with headers from the CSV file as row. So that's just referencing each row, and then we're just limiting how many we get back. So we just want to see one row. And if we do that in the Neo4j browser, which you get when you download and launch Neo4j, this is what you would see. And you hopefully get the hang of it. You get a map where the key comes from the header row of the CSV file, and the value obviously comes from each row. So you'll get a different map for each row. And if we look at it, this is exactly the same as what was in the CSV file. So we have a buyer club URI, and that maps to the first row in this case. We've got player age, same thing, transfer fee, and so on. So this is the data that we get back for in row. So row effectively has a map of data. What we can do with that is we can then use it to create some constructs in the graph. So what we might start up with, let's go in the same order as we did for the relational database. So we decide we're going to start with the players. And what we do here, so we're saying I want to create, so I want to loop through transfers.csv, and for each row, so implicitly it's iterating over the file. So for each row, I want you to create me a node that has the label player and has these properties on it. So we want an ID, and I want you to get the ID from player URI, name, player name, position, player position. And we can run that, and it will create us all the players. But we often might want to be a bit careful when we're doing this. So by default, there's no schema on the database. You actually have to put it on. You have to actually apply it if you want there to be something. And so in this case, if we run this query multiple times, or if there happen to be duplicate players in our CSV file, we're going to end up creating the same player lots of times, which probably isn't what we want. So actually what we want to do is we want to make it use a constraint. And I'll explain these in a bit more detail, but effectively what we're saying here is I want to make sure that when we have a node which has the label player, the ID has to be unique. So it won't allow me to create the same player twice. And so we can have a look. If we create that constraint and run the load CSV again, then we'll see an error along these lines. And perhaps you'll see, obviously, depending on your domain, you'd see something different. And but in this case, what it's saying is actually I can't run that command because you've already got a player with that ID in the database. So in this case, it picked up player 84682. Was the one that it got to first, and that was so it said that one's already there, so I can't create it. And so you probably want to use in most data sets there's some invariants you want to ensure, so you probably want to make use of those constraints. Equally, what you might prefer to do in this case, rather than using create, is actually use merge, and merge will actually ensure that it will make use of that constraint, but it will also kind of avoid the potential of getting the same data in your database twice. And the other nice thing that we can do is that using merge makes our script idempotent. So if we want to run it again, or if we run it by mistake, it's not going to cause any extra data to end up in there that we didn't expect. And so here, if you read it, it's quite similar to before. We've changed merge in here, and if you're using merge, the only property you need to put in here is the one that's acting as your identifier or as your key. And then what we've done here is we've said, well, if this happens to be the first time that if you are creating the player, then set some properties. But if you're not, then it's effectively just skip over the row. And you could put an on match on here and do some other operations if it was finding a player that was already there. But in this case, there's nothing to do, so we just don't do anything. Okay, so that's the players, and we'll do the same for the clubs. And remember, we don't want to get duplicate clubs. So we remembered from our previous experience with players, we've got to get that constraint in there first. So we're going to create a constraint on clubs to make sure that the ID is unique. The ID, remember, comes from the API of Transfer Market. So they've defined what makes a unique club. So we're just going to use that. And if you were doing this in your own work, expect there'd be some sort of identifier. Either you could define one. If it's a completely new application, or if you're importing data from another one, then there probably is already some sort of key defined that you can use. And we'll do the same thing here. So we'll iterate over the file. So we're going to go over the transfers file, and we're going to create an entry for each club. So merge the club, and then again, same thing. If we're creating it, set the name, set the country. and then we'll do the same thing. So we're going to do it twice. So we're going to do it for the selling clubs on here, and then we'll do it for the buying clubs as well, because they're in separate parts of the CSV file. Okay, so now we've got some players, we've got the clubs, but it's not very much of a graph at the moment, so it's a bit disconnected. There's just a load of nodes sort of floating around. There's no way to go between them, so we need to resolve that. And we're going to do that with transfer. So now this is very familiar to you now. So we're going to create a constraint on the transfer. So we've got an ID that allows us to identify transfers. So we'll create that. And this one's a little bit more. There's a little bit more work involved in here, so we'll go through this one a little bit more slowly. But don't worry if you don't, if it doesn't all quite make sense. Corey will be sending around the slides afterwards, so you can always read through it a bit more slowly if I go too quickly. But we'll go through it line by line. So from the top, we're saying I want to load from the CSV file again. And remember, we've already created all of these, the first three. So we've created the players and we've created the club. So we're just going to use the match. So it's going to say, find me the player. Find me the club, find me the source club, find me the destination club. So that's three things. So I've got players and clubs loaded. Then we're going to merge the transfer. So if the transfer doesn't exist, so it probably won't exist because this is the first time we've run it. Create the transfer. So now we've got four nodes. We've got the player, we've got the source, we've got the destination, we've got the transfer. And again, we do the onCreate on the transfer. But we've got our four nodes, and now we're going to build the graph. So we're going to say merge. So again, same thing as before. So if this already exists, we won't create it twice. So I'm going to merge from the transfer. So T is referring to this T, and player is referring to this player. So I'm going to create a relationship. So this is a relationship in here for called off player. So merge, transfer, off player, and then we're going to use the player age that was in the CSV file as a property on a relationship, and that's going to go to the player. And we'll do the same for the to define the from club. So we're going to go transfer from club source, transfer to club destination. And so now we've got a graph. So we've got transfer sitting in the middle, it goes out to a player, it goes out to a from club, and it goes out to a to club. And so we've got a nice graph. Like it's a decent start for doing some interesting queries. So now I'll just do a little bit of a detour on schema. So people are often quite curious. Well, I'm really used to setting up my schema in a relational database. How does that differ in a graph database? So let's have a quick look. So we've touched on this actually a little bit already. So some of this will be a bit of revision. So Neo4j kind of works with the idea that we have what we call a schema of optional schema. And so the idea is when you start, there is no schema at all, but you can apply it as you go. And at the moment, we've got 3 bits of schema. And I think over time we'll add more, but these are the ones that are there at the moment. So we've got the unique node property constraint. So this is the one that you've seen. And this is the idea that on a label property pair, so i.e. label, club, property ID, we want to ensure uniqueness. We don't want there to be 2 nodes that are the same. So that's that one. You can also, there's also a node, what we call node property existence constraint. And that one is effectively stopping nulls. So it's saying, or stopping the non-existence of a property even. So what we're saying here is, if you create a node that has the label club, then it has to have a name property on it. So this would be a way. I mean, we could do the same thing for ID as well if we wanted to. So we could say, if we combine the two and say you have to have an ID and it has to be unique, then effectively we've got the equivalent of the non-null primary key in a relational database. And then we can also do the same thing for the relationship. So we can say when you've got a relationship, you have to have a property on there as well. So that would look like this. So what we're saying here, create constraint on. This is just saying there's a node there, and it's an anonymous node because we don't really care what it is. It just has to be a node there. And then there's a relationship called off player to another node, so we don't care what it is. And what we're saying is whenever you get that relationship, you have to have the age property. So if you tried to create a off player relationship and you didn't put an age property on there, it wouldn't create it. So that's what these are for. They're for some tools to help you, along with the stuff that you put in your application, obviously ensure the invariance of your data. Okay, so but enough of that. Let's have a look at some queries. This is often the most fun bit. So let's do a bit of a comparison. And we'll start simple and we'll build out to something a bit more interesting. So we're going to start really simple opening query. So we're going to try and find a player by name. So and we're going to use Cristiano Ronaldo. So we're going to try and find Cristiano Ronaldo in the database. And this is what the SQL query might look like. So we're going to say select star from players, where players.name equals Cristiano Ronaldo. So it's quite simple. It's just going to get us one row. This is the equivalent cipher. So we use the match keyword here. So you notice now we've got rid of load CSV. There's no load CSV in here anymore. We're just going to go straight into cipher constructs. So we're going to say match Cristiano Ronaldo. So go and find a node. So go and find a node that has a label player. So remember, this is where we're using the label. So we're saying I want to find a node that has this label and has this property. And we can do this with a where as well if we want, or we can inline it. So we could say match player where player.name equals Cristiano Ronaldo, or we can inline it, and it's the same thing. So you might have seen the other approach elsewhere. So that's that bit. So that's equivalent. So the from and the where is the same as our match, and then the select star is equivalent to return. So that's another little bit difference in the two languages that you might find when you first get started, is that you might be used to going, oh yeah, I need to define all those things that I'm going to return at the front, and now in Cypher it's actually the other way around. So you actually don't need to say what you want to return until you get to the end. So that's something to keep in mind. And if we run that query, we'll get back Cristiano Ronaldo. So we just get back our single row, and there he is. So far, so good. Let's do something a bit more difficult. So we're going to try and find transfers between two clubs. So what we want to do, so if we read from the end, so we're going to say we want to find transfers from Tottenham to Manchester United, and the way we're going to do that, so we've got to do a query to find on the transfers table. So that's where the data is, and then we're going to join the transfers table to clubs twice, once for the from team, once for the to team. So that's these two lines. We're going to join it to the players table so that we can get back the player name. Right, so that's the SQL version. So we've got a few joins there in the middle, and then we've got a bit of a filtering. In Cypher, it would look like this. So in this case, so again, we can read from the end. So we're saying the from.name is Tottenham, the to.name is Manchester United. How do we map that back into the match? So the from is there. So we're saying there needs to be Tottenham there, Manchester United there. And then all we're saying is, and the way the Cypher planner would work would be that it would actually realize, you've got some labels, property label combinations here. So I'm going to pick one of these. I'm going to either start from Tottenham or I'm going to start from Man United. Let's say in this case we start from Tottenham. So we'd start here. We go, okay, cool, it's one node, and then we can follow that relationship out. So we can go and look up that relationship. Then we find the transfer. And then we'll go to the other side and we'll go and find what clubs there are. And the nice thing about Neo4j is that you can query these relationships coming into a node or going out at exactly the same speed. So there's no penalty to searching things coming in or out. They're the same cost. And then once we've done that, because we want to link into the transfer again, and we've already got two relationships coming in here, so the one-dimensional space makes it a bit difficult. We've got to put a comma, and then we'll connect to the player. But when this gets compiled, it all ends up being exactly the same. So the comma doesn't really make any difference. It's purely a helpful thing or a readability thing. Okay, so let's see. So which bits of those queries map to each other then? So you're quite familiar with this bit, the select and the from. We did that before, but we haven't seen any joins. So this is how the joins work. So the from this line here, doing the from join is equivalent to this relationship here. The to club relationship down here is equivalent to our join here, connecting the club to the transfer, and then finally the player one is equivalent to our player join up there. So we've got three joins, and we're able to find the transfers between two teams. And if we run that query, this is what we get back. So we get back 3 players. So there's only been 3 transfers. One of them in the late 90s, and then the others in the one sort of a little bit into the 2000s, and then one about 6 or 7 years ago. So those are our 3 transfers. And I'll do a little bit of a detour here. So a question people often have is they hear about indexes. So I've kind of mentioned indexes in there, and they're like, oh, how does this work? And the common approach in SQL, this often works really well, is if the query is not working particularly quickly, you go and index a whole load of things, and then that tends to be the silver bullet, if there is one, that solves all your SQL woes. But what is different here is that actually if you did that in a graph, it probably doesn't make much difference. And the reason is because indexes are only used to find the starting points for the query. So I find this people quite like this as a comparison. So in the relational world, we're kind of going and doing queries to get sets of data. So imagine index scans or table scans, and we're getting lots of data, and then we're doing set intersections on them to get some results. Contrast that with the right-hand side with the graph, where what we're doing instead is we're using indexes only to find the starting points. So in the queries we've seen so far, the starting points would be Cristiano Ronaldo or Tottenham or Manchester United. So, and you can have multiple of them, but once you've found them, then indexes aren't used anymore. Then it's all about pointer hopping and following those relationships that we've written to disk and are then loaded into memory and following those around and finding what's at the other end and so on. So that's something that people sometimes find a little bit interesting when they first start playing with Cypher. So now you know about that. And we can actually see using the profiling tool. So if you prefix your query with the word explain, which will just show you the query plan without running anything, or you can use the keyword profile, and that will run the query and show you the plan at the same time. You can get something like this. And to work out what indexes are being used, if you've got some defined, you will be looking for the operator node index seek, and that will indicate, oh yeah, there was, so in this case, this is the query plan from our previous query. It was actually starting from an index on the 2 club, so Manchester United in this case. Then it was following the 2 club out to the transfer. Then it did a bit of filtering on the transfer, and then there's a lot more to follow it. I've chopped it off. Okay, so that's right. So there's some queries and a bit of an explanation of indexes. So what we're going to do next is have a look at, let's try and make the model a bit more interesting. So it starts, we've only got a few tables. We can do some reasonably interesting queries, but there's still some scope for improvement on the model. So let's do that. So in SQL, this is known as migrating your model, and in Neo4j we call that refactoring, but they're effectively equivalent. But let's do some of that. So if you were eagle-eyed, you'll have noticed at the beginning when I was showing the data set that we've actually left off one of the columns. So we had a player nationality column, and I just left it off. I completely forgot to add it in to the table, and obviously then into the node. And I thought, I could just go back and add it in. But then I thought, maybe we could do that as an example of migrating the model and adding in an extra column instead. So that's what we're going to do. So we want to add in a column to the players table. So it's not a complicated operation, but let's have a quick look at what we're going to do. So we'll do the relational one first. So all we're adding, so the model stays the same pretty much. We're just adding in nationality down here. And as you would imagine, we're just going to add a new column, and 30 is roughly the maximum size of any nationality. So we'll create that column. And then we just need to go over our existing records and add a nationality to them. So we're going to go update players, set nationality for that particular player. So that's fine. Graph refactoring is equally simple. We're just going to add in a nationality onto the end as a property to player. How are we going to do that? We're going to take the CSV file, we're going to iterate over it, we're going to match the players. Remember, all the players are already there from before, so we're just going to get the player, and we're going to set the nationality on it from the file. And that's it. So that's the equivalent. So quite simple. We've now got nationality available to us. There's not much point putting nationality on unless we're going to do some queries on it. So let's do that. So this time we're going to find transfers of English players. We're going to go and look up players who are from. So it's actually a little bit more than what I said. So it's English players being transferred between English clubs. So it's a very English query. So there's no prizes for guessing where I'm from. So if we go through, so you've seen some of this before. So you've seen the joining on clubs and players. Or the only bit we've changed is that we're now doing, instead of looking up specific clubs, we're going and checking the property. So we're saying club from country is England, club to country is England, player nationality is England. And then the same thing in Cypher. The query is exactly the same. The only bit that's changed is this where down here. So I'm saying where, and that is basically the same as the Cypher. It's just got some different variable names. And these are the equivalent. That's the equivalent of using the column that we've just added in. So we're just going to go and check everywhere is England. And if we run that, this is what we'll get. So these are the English players who have been transferred between English clubs. These are the highest transfer fees for those players, and you can see they're spread over some seasons. And there were some actually I didn't actually know about, so it was quite an interesting query to write. Okay, so now let's do a little bit of a more more hands-on, a bit more difficult migration, let's say. So we've got, remember, we've just added in nationality, and we've got countries in there. What I thought would be interesting would be to introduce confederations. So a confederation is actually a country-specific thing. So it's which football association does a country play under, and so they'll be using that. They'll be governed by that. So that confederation, and they'd be like, for example, trying to qualify for the World Cup. They'd be playing against the teams in the same confederation. And this is what the data looks like. So FIFA website has a whole load of countries, and then the matching confederation, and then for the confederation we can get a bit of metadata about it. And so we're gonna make this a bit more normal form than it is at the moment. So you remember that we had country inside the players table and country inside the club, so there was a lot of duplication in there, and it makes it really easy to make a typo and not realize that actually the country that you've typed in isn't actually the same country as what was meant to be the equivalent one somewhere else. And so in those cases, it actually makes sense to pull out a countries table. So that's what we're going to do. So we're going to pull out a countries table. We're going to link it to players via a country ID, so foreign key, primary key over here. We're going to do the same for the club. So remember, a club had a country, so we're going to link that directly. And we're going to do this, and then this is our new bit here. So we're introducing a new countries table and a new confederations table, and they're also linked together. Okay, so let's do the drill again. So we're going to create the confederations table. So this has a primary key, some properties, and then we're going to populate it. So there's only 6 rows here. So actually, this is really easy. So we're going to get that table populated. Then we're going to create the countries table. So we don't have this. Remember, we do have countries, but they're not in their own table. So we're going to create the countries table. So we'll create a key, and the only interesting thing here is that we are linking it to the confederations one, so we want to make sure that the country has a valid confederation. Then we're going to populate the countries, so we get the code. So this is going to be our key. This is the FIFA code for each of the countries. So SUI is Switzerland, ARU is Aruba, and then we've got a key linking them to a confederation. So that's hopefully reasonably straightforward so far. Then we're going to add a column to the clubs table. So we're going to add a country ID, and we're going to link it on the code to the countries table. So adding it to the clubs and linking it to the countries code, so that you can't put in an invalid country ID. I can't say that this column is not null yet, because remember, we're adding it and there's no data in it, so I can't be that strict just yet. But the next bit we're going to do is actually go and set those country IDs. So we're just going to do an update query that joins the clubs table to the countries table, and goes and looks up the appropriate row in the countries table by matching the name that's in the clubs table. So the clubs table already has a name, remember, with those countries in. So we're just going to go and look up the appropriate country in the countries table to map them back, and then we're going to set it up here. So what we'll end up with is actually something looking like this. So we'll have a bit of duplication. So we'll have this is a select query from the clubs, and we'll have the country in it still in there, and then we've got the matching country ID as well. And then what we might choose to do, we might not do this straight away, is we could choose to drop that country table. But what we might actually choose to do is actually make sure that the migration works okay, do a few test queries on it, and then we obviously have to go and migrate any existing queries we've got. And we have exactly the same things to think about when we're doing the graph, as we'll see in a minute. But we're going to drop the country. Now we're going to do the same for the players. So we're going to add the country ID table. We'll link it to the countries on the code. We'll do the same query as we did before on the players. So we're updating the players based on matching on the nationality this time rather than the country column. And then if we have a look on the players table after we've done that, it's this same sort of thing. So we've got some duplication in here. So we've got the nationality and the country ID. So England, Netherlands, NED, Poland, POL, for example, and that's just a limit of 5. And then again, we can choose. We don't have to do this all at the same time. We might choose then to drop the nationality as well, so that we don't accidentally use it. Okay, so that's the relational one. So hopefully that was quite familiar, and you've done something similar before on the projects you've worked on. But let's have a look. What would it look like if we did the same thing in a graph? So this is what the model's going to look like. So you've seen this left-hand side of the model already, and the bits highlighted in red are the new bits. So we're linking player to club to country. So player plays for a country, club is part of a country, and then obviously the other club's part of a country, and then country's part of a confederation. So the process is the same as what we've done with the relational database. We just have to have named the relationships here rather than having them as primary and foreign key links. Right, so let's see how we're gonna refactor our way to this new model. So step one is the same as what we did with the relational stuff. So we're going to go and create the confederation. So you probably get the hang of this by now. So we're going to iterate through. This time it's a different file. So we're going to iterate through the confederation file. We're going to make sure there's a confederation. We're going to use the URL as the ID, and then we're going to set the properties, so short name, region, and full name. Then we'll do the same for the country. So this one's a little bit different. So the first bit's the same as what you've seen already. So we're going to go iterate through a different file this time. So we're going to iterate through the countries file. And we're going to make sure that the country exists. So create the country or merge the country if it's already there. And then this bit's a little bit different. So this is the first time that we're introducing the with clause, and this is used to effectively combine two parts of a query together. And the reason that we have to use it here is because we've done some create work here. And so you can't do some create work or potential create work followed by query work. So if you have a query and you create something or merge something, you have to use a with if you then want to do another read query. And the reason that we're doing it here is we're saying iterate through the file, make sure the country exists. If it doesn't already, then I want you to go and look up the confederation. And remember, we just created the confederation. So go and look up my confederation. So that's what this is mapping. So it's coming from the row. So find my confederation and connect me to it. So connect the country to the confederation. So the country we just created, the confederation we created before, and now we're going to link them together. So you can kind of do this combination of create some stuff, look up some stuff, and then go create a relationship. So you can kind of do all sorts of combinations of these things, and it's quite the with keyword is quite a nice one. So I would suggest having a look at the documentation for that if you haven't come across it before. So that's the countries. So we've got the confederations, we've got the countries. Now we just need to do a bit of club refactoring, and this is reasonably easy. So this is the equivalent of that update statement that we had for the SQL. So we're going to look up all the clubs, so match clubs, then match the countries that have that match the country property on the club. Next step, create a link between the clubs and the country. So that's creating the part of relationship. And then finally, we'll get rid of the property. And equally, as with the SQL version, if we didn't want to get rid of it just now, we could choose to leave it in there and delete it at a later point. And for the players, it's almost exactly the same query. We just change where it said club, make it say player, where it said country, here, make it say nationality. Otherwise, the structure is the same. Go through the players, find the appropriate country, create the relationship to it, drop the original property. And that's it. So now we've got both the models evolved towards our new structure. So if you remember, it's probably about 10 minutes ago or so, we did some transfers of English players, and you remember it looked like this. So we had our SQL version up here, and it looked like this. We did a few joins. We did joins on clubs and players, and then we had our Cypher version down here, where we were matching patterns in the graph to go and find the same thing. And that query obviously changes because we've got rid of the nationality column, we got rid of the country column, and we've introduced like a whole new table in the relation set. So we've introduced a new nodes in the graph. So the queries obviously have to change to go with that. So let's have a look. So how would we do that? So this is what you end up with. So the new bit is here in red. So this bit's all the same. So you've seen this bit already. What we've added in is we've now got to join the countries. So we've got to join the country that the from club is linked to based on that foreign primary key. We've got to do the to country, we've got to do the player country, and then we're going to go and check match the countries down here. And this time we're doing it on the country table rather than on the player or club. So that's fine. So now that gets us all the English transfer, so player who is English going from a club that's English to a club that's English. In Cypherland down here, you can see it's a little bit different. We don't need to go and match properties on 3 different things. We can actually just say, actually, there's England is going to be there, and I can just use the same variable name everywhere. So I can say, well, I'm looking for a player who plays for England, so I've got England there, and the to club in the transfer needs to be part of England, so it's the same one. So this is the same. This country is the same as this one, and the from club needs to be England. So we're just using the graph to kind of say, well, actually, everything needs to center around this one node here. And if we run it, we'll end up with the same result as we did before. So we won't bother repeating that. But hopefully you can see this. So this is where a graph works quite nicely. Where we don't need to go and match on property names. Like we don't need to go, well, this is the player country and this is the to country and then it's the from country. We can just say, well, there's a node there and it happens to be the same one that they're all linking into. This is quite nice. This is actually making use of I suppose we call it making use of the graph. So we're using the structure to write nice queries. Okay, but let's see. Right, so we've got confederation, so we can probably do some few more interesting queries. So let's have a look at some of those. So we're going to find transfers between 2 different confederations. So it's going to be between the Asian Football Confederation and the European one. Hang on, we'll go through this one. So the extra bits are down here. So you've seen all this. This is just joining clubs and players and countries. All we're doing extra is we're joining confederations to countries. So we're saying that those countries need to map there and those countries need to map here. And then our query, our filtering clause is just checking that the from confederation is the Asian one and the to confederation is the European one. In Cypher, it would look like this. So this bit, the top bit, you're very familiar with already. The last 2 lines are a little bit different, and this is what we call variable path query in or variable path length query in Cypher. And so what we're saying here is here is the from. So remember that's the from club. And I want you to go 2 hops. So that means go traverse 2 relationships. So from, remember being a club, is part of a country. So that's kind of the hidden thing. And then we're going to go part of again. So we're going to go out to the confederation. And then because they have the same relationship name, we can do it like this. And we can do the same thing for the to. So we can say to has, there's 2 part of relationships going out up to a confederation. Can you go and find me that? If there was another layer, we could put a 3 in there. Equally, you can play around with that and put in various different numbers. In this case, 2 is the one that we want. So that's quite interesting. So that's a variable length path. And if we run that, we'll get all the queries that are in that are between those 2 confederations. And you can see that the speed that it takes is very quick. So it's optimized for traversing these the relationships between the bits of data. Okay, so that's all for the query. So what we're going to do, we're going to wrap up a bit with some common questions about that people often ask when they're trying to compare these things in the head. The first thing is, what's in my database? How do I find it out? So in Postgres, if I want to get a list of all the tables that I've got, it's quite easy. I just do /dt describe tables, and I get back list of my tables. It tells me what schema they're in, who's the owner. In Neo4j land, if you open the Neo4j browser, on the top left-hand side of the page, you get the equivalent of that, which is node labels. So that will sit in there, and you kind of see exactly the same data. From the 3.0 series, we're actually making it possible to get that as a query that you can run, and it's available as a procedure. So we've got one called DB labels, and it will give you back all the labels. You can do the same thing for the relationships and properties as well. So if you've used Neo4j already, you'll remember that on the left-hand side there's a panel that shows you the whole schema. So this is what is actually calling to do that. In SQL, we can get a table schema, so we can just go, hey, tell me the schema of countries, and it'll go, yeah, here we go. Here's the columns, here's the primary key, here's the constraints. This is how it's linked to other tables. This is how you do a similar thing in Cypher. So if you type in :schema into the browser, it'll show you all the indexes that you've created. Remember, we did some unique constraints, so it'll show you those as well. And actually, one thing to keep in mind is whenever you create a unique constraint, it automatically creates an index for you. You can also run queries to actually go and explore the schema yourself. And I probably wouldn't do this on a really massive graph, but on a small one like this, it's reasonably okay. And if you've got if you still want to do a query like this, you can probably take a sample of the data and have a look what is actually showing up. But in this case, what we're doing is saying I want to go over all the countries that I've got and return get me the keys. So the keys being the properties, and tell me how many times each combination of keys shows up. So for countries, there's not really anything interesting. Everyone has ID and name. For club, it was a bit more interesting. It was something that I wasn't expecting, actually. So I got back ID and name 806 times. I was like, cool, that's good. That's what I expected. But I had one where it didn't happen, and it still had a country on there. And I'll explain why that was in a second. But this is perfectly valid. So it is perfectly valid to have a node of the same label having different properties. So it would be common for you to see that in a typical graph model. In Postgres, there was a tool I could get called PG Schema that I could just generate a schema from. So this is the schema of the database that we've got at the end. In Cypher, we've got what we call the metagraph, and you can generate a diagram, a visualization like this using using a procedures package that's available, and it will give you just a visualization of what is in there. So, country is part of a confederation, club transfer goes from a club. Player plays for a country, and so on. You kind of get the idea. This is one query that you can run to do that. There's no need to remember this. If you Google for metagraph, Neo4j metagraph, you'll find it, and you can just you can copy paste in. We're also working on a procedure that will just do this directly as well, so you won't have to type anything. Okay. Right. So getting close to wrapping up. So let's have a quick look at data integrity. So how would we do this in SQL? Well, we can write queries. So along with the schema that we've got built in and the null checks and so on, we could go and check. Remember that country ID? We couldn't put a null check on because we added it in as a new column with no data. But when I was running it, I was noticing that it didn't seem like that as many rows were being updated as I expected. So I had a little quick check, and it's like South Korea, Cote d'Ivoire, and Monaco. This is actually the most interesting one. Didn't have a country ID, and the reason for some of these was just the spelling from the different data sources, and then Monaco is actually the odd one out because Monaco is not actually a recognized country by FIFA, so it doesn't appear as one of the valid countries, but obviously is a country, and so we could either choose to just leave that as it is, or maybe we're going to put it in France, but perhaps people from Monaco would be very upset with us. In Cypher, we can do the same thing, so we can write a query and say, find me clubs where there's no relationship to a country. So we could do that. Another thing that people sometimes run into is deleting data. And this, if you try to, for example, drop the countries table, we'd get a message a bit like this. It's saying, you can't do that. That's actually connected to by other tables that depend on you. So you can't just do that. You'd have to do a drop cascade if you want to nuke the countries table. Exactly the same in Cypher. So if I try to nuke the countries or get rid of all the countries, I'd run into this problem here. So it'll say, hey, that node can't be deleted. It still has relationships. So you have the same thing. You can't just delete a node when it has relationships attached. However, we have exactly the same sort of thing as SQL called detach delete, and that will go and take out the node that you're asking and get rid of any relationships attached to it. I'll just do a little bit on query optimization as we wrap up. We're not going to spend a great deal on this. But effectively, the main thing is you can profile queries. So if you put the profiler on it, it will normally indicate some operator that stands out. If you can't interpret it, hopefully you can find someone on Stack Overflow or on Twitter who's able to interpret it for you and help you. But basic ideas are you want to use indexes on the starting points of queries. If you're writing really complex queries, you want to limit the work in progress going through the query. Often you'll end up with lots of things that are actually the same at the beginning of the query, and there's no need to repeat the same effectively next part of the query, and so you can actually filter that down. And then another useful thing is that the Neo4j browser actually now gives you warnings when you're doing what it thinks are bad things in your query. So it pays to look at those. We've actually got a talk on this from GraphConnect San Francisco last year called Tuning Your Cypher. So you can grab that from the slides when you get those from Corey tomorrow. There's also a blog post on query tuning which you can have a look at. And as I mentioned, Stack Overflow, or we have a Neo4j Slack channel that people use. And finally, I've mentioned this already, but quickly to show you. So from Neo4j 3.0, we'll be having procedures. We've actually already seen an example. That was the DB labels example. My colleague Michael, pictured here, has been creating a set of these that cover all the things that Cypher doesn't have at the moment, or are extra things on top of Cypher. And I'll do a quick kind of example of one of them, just kind of not related really to any of the rest of the content, but just for fun. We're going to do a bit of querying of GitHub using a procedure that Michael's written called load.json. So we've got it here. We give it a URI, and it will go and load that and give you the ability to treat it, to process it in Cypher. So we get back an array of items, and we're going to iterate through them. So that's what the unwind function does. It kind of takes an array, explodes it out, and then all we're doing is just we're saying, give me back every repository on GitHub that has Neo4j in the name, and tell me the one that has the most forks. So just a fun final query to show something unusual, perhaps, that you can do using the procedures. And what we get back here is the Neo4j project comes up top. Then we've got a bit of Spring, got a bit of PHP nodes in there as well. Jim Weber's tutorial. And there we go. So that, and there are lots of other ones. If you look up that package that I've got linked on the previous page, you can go and find all sorts of other stuff you can do as well. And with that, we are back to you, Corey.
All right. Thank you so much, Mark, for that excellent presentation. And I know we are right up against the time for today, but we do want to remind everyone that we will be sending out the slides and the recording from today's presentation. So thank you so much for joining us. And for the next few minutes, we will go ahead and take questions. So if you have them, feel free to enter them in the GoToWebinar control panel right under questions, and we will go ahead and begin answering those. Mark, I'll go ahead and ask you the first question now. It is, could you please review the pros and cons of modeling transfer as node versus relationship?
Okay, so I'm assuming that would the idea would be that we would have a transfer going directly between the clubs. So we'd have club, and then we'd have a transfer relationship going between them, and perhaps we'd put the information about the player onto that relationship, and perhaps the other information as well. So the reason that I have transfer as a thing in its own right was so that I could do queries where the player is like a first-class citizen. So for example, so we could have a look at all the find all the queries, all the transfers that Cristiano Ronaldo was involved in, or actually a more interesting example would be perhaps someone like Angel Di Maria. Find all the queries of a particular player, find all the transfers of a particular player easily. And what we can do by having transfer connected to a player node is that it allows us to very quickly go to the player, go and look up all their transfers and get a result. If we didn't have that and we were just storing all the information on the transfer, then we'd have to go and scan across every single transfer that we've got and match the in this case the player name to find the transfer that we want. And that's actually quite an interesting. It's actually a refactoring that effectively shows like how you can sometimes end up with entities hidden as relationships. So often when you start, it does make sense. It's often better to start with a very simple model and then evolve it as time goes by. And so often what you'll do is you'll start with a model where you've got stuff modeled just as relationships, and then over time you're like, oh, that actually would be a really interesting thing to be able to start our queries from, or pull out and be able to do some other connect some other interesting things to it. Perhaps over time you might pull out a node that started as a relationship. Hopefully that.
All right, excellent. Our next question, it's a bit of a long one, but here we go. In my project, I have many different data sources. Data sources pretty much have the same data, but the attribute names are different. For example, latitude and lat. Could I create labels for these attributes and query with the label, or is there another better way to manage this type of inconsistency?
So what I would do there is actually just take the data, load it in, and then maybe run one of those kind of I call it an integrity query that I was that I ran at the end. where you could have a look at what properties were there. And what you could do is you could say, maybe you decide actually latitude is what I want things to be named, but my data set's got them as latitude, and you might maybe you choose just to load it in as the data is. And then, so I showed how you could remove a property. So you can also rename a property. So we can take the value of one property and put it as a different name. So what we could do is go, well, actually there's 7,000 called latitude, there's 200 called lat. Let's go and find all the ones that have the lat properties. You can write a query to do that, and we'll take the value and put it onto a latitude property instead. So I'd probably do that. You could do it with a label as well. You could say, go and find me all the nodes that have the property latitude or lat, and put it as and put a label called latitude. But I'd probably do the other way, just and fix the data.
All right, excellent. Thank you so much. Our next question is, how and when is the head keyword used?
Yeah, so the head keyword is actually applicable when you're working with collections. So I don't think we really had any collections in any of the examples I showed, but if you had a collection, for example, let's say you had a collection of numbers, head would allow you to take the first number off that list. It would be equivalent to using square brackets of 0 notation on the end. The place where you might have seen that would be when we're using collect. So there's a keyword called collect, which allows us to do an aggregation where we kind of grab whatever is inside the collect statement into an array, and the head would then be to say, well, actually, I just want to get the first item in that list. And we have kind of Python-esque syntax that would allow you to go, I want to get the first 3 items in the list, or I want to get the items between position 2 and 4 in the list, or I want to get the last item in the list. So there's lots of different ways that you can play with collections. Although I didn't happen to show any examples, that's obviously still quite a common thing that people do.
All right, and since we are running out of time, we'll take one final question, and it is, I believe, regarding the Cristiano Ronaldo example. It is, why was the player age stored on the relationship, but the fee and season were on the transfer node?
Yeah, for that one, to be honest, for that one, there's not really any reason why you couldn't put that on the transfer node as well. There wasn't any particular domain reason for that. I guess with that age, it would actually be better if we had the date of birth and we could just put that on the player and calculate it. I was trying to think of something to put on the off player relationship to show that you could put that you could create constraints on there as well, and that was the one that I thought that one seems like it could go on there. But yeah, equally, there's no particular reason why it has to be like that, since every transfer is always directly connected to one off player relationship.
All right. That's all the time we have for today, but I do want to thank everyone so much for joining us, and thank you for submitting your questions as well. And thank you, Mark, for that excellent presentation and examples. I'll remind everyone that we are sending out the slides, the link that's pictured on your screen right now, as well as the recording via email, so make sure to check that tomorrow. And thank you so much for joining us today. We'll see you on another webinar soon. Thank you.